Hi everyone, I'm Rashmi Nagpal. I'm super sorry I'm not able to present in person, but virtually I'm just super excited to share my learnings with all of you. And I see so many people here, but it's like very tiny, but I'm really grateful to people who are attending this session. Okay, so without any further ado, let's begin. And the presentation or the title of my talk is The Aesthetics of the Unbiased Learning Systems, Crafting Fairness in Practice. And just a little bit about me, I'm Rashmi Nagpal. I'm a software engineer by profession and a researcher by passion. Okay, so without any further ado, let's begin. So the agenda of the talk is firstly, actually, let me do it like this. Okay, we'll understand what is machine learning and its related concepts. And then we'll understand, the code black box problem, why machine learning sometimes give unfair biased decisions. And then what are the strategies that we can use to build fair and unbiased machine learning models. And towards the later part of the session, we'll understand what are the levels of the testing in the machine learning testing paradigm. And again, towards the end, I'll explain how we can incorporate explainability while we are developing ML systems. And towards the end, I'll just leave you with a bunch of resources and of course the conclusion or just the key takeaways from my talk. And if you have any questions, I'll be more than happy to answer that. So let's begin on this exhilarating journey together. Okay, introduction. So first of all, just wanted to bring all of us on the same page. For the people who are not aware about machine learning domain, so it's better, we should have the basic background for mental before. Okay, so, AI, it's kind of a very broad term. And basically, it implies that you are developing a program or a technique which mimics the human behavior. While machine learning, it's a subset of the AI in itself. So in which you are not just developing algorithms, but also the algorithms are learning from the data set, whichever the data set is being given, and learning from its corresponding features in it, then gives you the output. While the deep learning, it's a subset of the machine learning, which extracts the patterns from the data set, and then it gives you the data-driven decisions. For example, as you can see in here, this handwriting recognition, it's an example of the deep learning. And the spam email detection, it's an example of machine learning. All right, so I have given just the basics. Now I want to test the waters. I think I can see people from here. I just want the people to raise the hands if you think, okay, let me phrase this question like this. I want you to take a minute and think which of these faces are real. Okay, now please raise your hand if you think face A is a real one. Please raise your hand if you think face B is a real one. I would highly appreciate the active participation. So, yeah, please raise your hand if you think face C is a real one. All right. Okay, so people, those who have raised hands for either of these faces, the answer is none of these faces are real. These people do not exist on the planet Earth, to say the least. I'm not sure about the Andromeda or, extraterrestrial planets. So these people, they do not exist on the planet Earth. And, this is an application of the deep generative modeling. So what happens in the deep generative modeling is the algorithms are not just learning the patterns from the data set, but they are also going a step beyond in synthesizing the brand new data instances based on those learned patterns. And you must have seen, the chat GPT, DALI, there's so much hype which is going on. These are also the deep generative AI modeling kind of an examples. It's a very incredibly powerful idea, I would say, which has exploded in the recent past. But wait a minute, what's the building blocks behind all these algorithms? And that's where the neural networks comes into the picture. So let's see that. Okay, so this is a very basic structure of the neural networks, which highlights, that you are given a data set as an input, and then consider machine learning right now as black box, which comprises of the weights, sum and bias, and activation function, and then it gives you the output. So output could be any use case that you are catering to, or whichever the use case that you are trying to develop. So that's how the structure of this neural networks looks like. And let's understand this entire structure through an example so that we can able to understand the gist of it. So that's my Maltese breed puppy. Puppy, that's a Fluffy. The name of my Maltese breed pet is Fluffy. Okay, so given an image data set as an input, you need to identify to which animal category that image belongs to. So here I've given the image, which is, I already know as a person, right? Okay, this is an image of the dog, but I want the computer to understand and just learn from the algorithms and gives me some data-driven decisions. So firstly, we'll feed this image data set as an input, and then the machine learning algorithm in itself will understand through in a form of a combination of zeros and ones. And then using image recognition algorithm, you will get some accuracy or with certain confidence. Okay, with 92% confidence, this image belongs to the dog category, or maybe like with 8% confidence, it's a cat category. So that's how you can use, such image recognition algorithm, or that's how the basic structure of the neural networks behind the hoods works into this. Okay. Now, if you want to deploy this kind of image recognition model or any possible machine learning algorithm use case that you're trying to develop, if you want to deploy that into production, so let's see how the entire ML system pipeline looks like. Okay, so here we can see that, the image, I would say the machine learning pipeline, which basically comprises of the three main stages. The first is the build stage, next is the deployment, and the last one is the monitor stage. So what happens in the build stage is that you're not just ingesting the data as an input, but you're also, doing some pre-processing, post-processing stage of that data. And then you are training the model, testing the model if you are satisfied with the accuracy / other evaluation metrics. Then you're packaging the model and registering before, shipping it to the deployment. And the deployment, it could be, like on the production environment or just the dev environment. And the last bracket which comes in, or the last stage of this ML pipeline comes in, is the monitor stage. So what happens in the monitor stage that, when your application is released in the production environment and it's made available to the end users, in the monitoring stage, you are not just analyzing, but you're also governing the the model that you have created. And you just reiterate that stage of the build stage back if there is anything which goes wrong. For example, sometimes you train machine learning systems on previous data set, like it was trained in 2019, now it's still in the production environment, or maybe like it's satisfying the use case, but it's not been trained on the new data set which has come from that particular time period. So the data on which it was trained must be a stale from the present day scenario. So that's why in the monitor stage, you go back to the build stage and just fix whichever the real use case environment that you want to fix it out. Okay, so this is a very high level machine learning system, or the stages, I would say, which looks like, but wait a minute. What if something goes like really wrong, and especially in the build stage of this machine learning pipeline? So let's see that. Oh, but before that, I just wanted to put out this word like 13%, if people are not aware about it. So there is a very famous article released by the Venture Beat, which states that, only 13% of the machine learning models, or I would say the black box, it just makes into the production. And the rest, so does that imply the rest, 87 of them, they are, made to, I would say they're laid to rest. So let's understand why such kind of a distinction, or why only, such a small fraction or just a percentage of machine learning models are into the production as compared to the lot of effort which has been put in. And before that, we'll also understand what is a core black box problem is, and the ways to mitigate that. So the core of the black box problem is, I'll just give a couple of examples just to give a brief overview of what is the problem all about that I'm trying to highlight in this presentation. So this example right now, it's a word embedding, basically you can see in this Cartesian plane, or I would say vector space, that the affinity of the homemaker towards woman is more as compared to the homemaker towards the man. I mean, I would say the affinity in the sense that the distance is less as compared to the women and homemaker with regards to the homemaker and the man, right? And this representation is one of the algorithms which is like very commonly used. It's a word-to-vec algorithm. Unfortunately, this algorithm is biased algorithm because it's trained on the biased data set itself. And we know that a very famous phrase is garbage in, garbage out. So if you have trained on biased data set, of course, the result and the output is going to be biased. So, in this example basically highlights that isn't necessary that the homemaker and the women, they are similar in the meanings, or maybe like they are a same. It's not necessarily true, right? In the real world scenario, of course, it can't necessarily be 100% true in all the cases. And this next example that I wanted to provide to all of you, I'll just give a couple of seconds so the people can actually read through the prompt. And it was like very shocking to me, to say the least, the response given by the chat GPT. But the reason behind providing all these examples is also one of my underlying motivation, is to make the people aware that the technology or the tools that we are consuming, are they inclusive enough? Or do we need to build, and how can we build such technologies which are so much inclusive and diverse, or I would say representative. Okay, so the prompt, which is what I gave to the chat GPT, is the doctor yelled at the nurse because he was late. So you can understand, right? The nurse was the one who was late, and therefore the doctor yelled at the nurse, right? So that's what logically is. It makes sense. And then the question is, who was late? So of course it's the nurse, because he was the one who was late. But the response given by the chat GPT is not just logically or factually it's wrong, but at the same time, the reference of the he has been gone back to the doctor. Here I've not explicitly mentioned that whether the doctor is a he or a she, but definitely the nurse was the one who was he, right? And the nurse was the one who was late. So that's a, that's surprising. That's so surprising and weird, at least to me. And the second prompt, if you can see that the doctor apologized to the nurse for her late arrival to the emergency room, because she arrived late to the emergency room, therefore she apologized to the nurse. And then who was late? Previously, of course, because the doctor was the one who was late, right? But the response given by the chat GPT is like, again, very wrong, in a sense that the change of the pronouns has happened, that he was the one who apologized to the nurse. Yes, I've explicitly mentioned that she was the one who was late. Okay, so the next example is, here you can see that the ChatGPT has itself given the use of the pronouns in the sentence makes it unclear. So here, ChatGPT has given the response in such a way that it is mentioning the user as me. The prompt that I'm putting in is the wrong usage of the pronouns which has happened. So unfortunately, that's what it is happening at the moment, in the sense that the bias is prevalent, and the everyday technology and the techniques that we use, it is also ingrained with it. Okay. So after seeing, a couple of these examples, now it's important for all of us to understand how did we get here? How can models sometimes, give such kind of a biased and unfair treatment or just output? In that case, let's see what are the reasons, underlying reasons behind it. So as you can see in this, I've not added the exhaustive list, but again, it covers the breadth of possible scenarios. For example, the biased training data set, historically the algorithms which are trained on the biased and of course on the discriminated data set, they will definitely perpetuate the bias, right? And it will also amplify the unfair decisions, not just towards the underrepresented sections of the society, but holistically, it will definitely hamper a lot of people within the society. So bias training data set is also like one of the entire culprit, I wouldn't say 100%, but again, one such reasons that why models give such biased and unfair decisions. And when you have the lack of diversity within the data set, it will definitely lead to some haywire results, or you can say that skewed results, as we say, garbage in, garbage out, right? So that uneven distribution, when you have like a diversity or representativeness within the data set, it will then produce inaccurate predictions or the data-driven decisions. And the third is the cognitive bias basically get introduced when the teams or individuals are themselves not aware about their own bias, either when they are developing or just building, or like deploying at the deployment, or maybe like the testing stage of the machine learning systems. And the last is when you have the inadequate evaluation metrics. So, when the evaluation metrics are not properly aligned, or I would say it's not clearly aligned with the objective that you're trying to achieve, then of course it will also lead to some haywire outcomes. Okay. Now it's time for us to understand the ways, or I think the ways to mitigate how can we actually build unbiased and fair ML systems or models, and what strategies that we can use to follow that. So this particular, here I've listed down like bunch of strategies that we can definitely use while we are building ML systems which are fair and well representative, or I would say the unbiased in that sense. So first and thumb rule is you need to collect the diverse and representative data, especially to the population whom you are trying to achieve kind of a use case that you are trying to develop or build the use case for, because that helps in reducing the risk of any potential bias which could possibly arise. Then using some pre-processing and post-processing data techniques that you can use. Maybe it could be some data augmentation techniques, feature selection, reviewing mechanisms, helps in balancing the data and of course, reducing the bias. And the third is the fairness techniques. There are a bunch of fairness techniques that you can use. For example, demographic parity, equalized odds, and so on and so forth. I'll go in detail with the fairness techniques in a couple of my slides, but before that, I think it's important to let you know, okay, there are some fairness techniques that you can use. And the fourth is, of course, you need to test your, machine learning pipeline end to end. We'll also see some demo in order to understand and, better able to comprehend the technical jargon that I'm right now putting in on. So, and the last and most favorite topic of me is like explainability. Just build the models that are so much transparent. And of course, they need to be like interpretable, because it helps in identifying or just correct any kind of a bias that may possibly exist in the system that you have developed. Okay. So let's see a quick demo of that I have prepared for all of you. And of course, this QR code right now shows that you can, if you just scan this QR code, then you can go back, you can access the code that I have written. And of course, the slides will be available, publicly available. So you're free to use that and just tinker around it. Okay. So the use case that I'm trying to right now show you about is so basically, I just want to show this certain strategies which I've described in my previous slide so that it's better comprehensible for all of us. And the use case that I'm working on right now, or the example that I want to give you, is about the loan classification. And the data set is the German credit data set, which is publicly available on the UCL repository. And what happens in that data set, like what are the features in that data set is, it has a status, duration, credit history, it has the age, gender, all these kind of labels are present in that data set. So of course, first you need to install whichever libraries that you want to use, and then loading the data set, defining what are the features of your data set. And you can understand the data set, which is the attribute distribution or description in that data set in itself. Again, on the UCI repository, which has this publicly available German credit data set, you can just tinker around and do the EDA process. EDA is called as exploratory data analysis. And so the first thing which I explained in previous, you should use some pre-processing and post-processing stages before you are trying to build your model, just to ensure that it doesn't inherit any bias. So here I'm using one of those techniques, and I'll show you, okay. So here I've converted all the categorical variables to the numeric using one hot encoding mechanism that we can use. And here we can see, okay, I've defined which are the sensitive features or protected attributes. Basically, protected attributes or the sensitive features are which are a user's information. Basically, it could be the age, gender, race, whichever demographics basically that user belongs to. And here the first strategy that I'm trying to use is applying the data augmentation technique. And here I'm using the SMART, which is synthetic minority oversampling. It's a statistical measure. Basically, it helps in balancing your data set in a balanced way. If there are some oversampling, like if there are some undersamples within your data set, then you can use this kind of a technique. As you can see that the count in the 0 in this data set, which was one of the target variables, is 569. But after applying the SMART technique, you can see it's 700. Similarly, for 1, it was 551, but after applying the SMART, it's 700. Then that way you can use the SMART, one of the data processing, when you're doing the pre-processing stage before you're doing the modeling. So that's how you can use the data augmentation technique. And once we have done this, now you can train your model. So here I'm, for the demo purpose, using this XGBoost model because I want to do this loan classification given on certain attributes, right? You're free to explore other tree-based classifiers. Maybe you can go away with the BERT or the Roberta. These are very high-level models of the transform-based models. But for the small demo purpose, it's better to go with this one. And so XGBoost, and of course, you're also free to use this in neural networks. But I think, it's it's more gonna be, like, just start with a very naive approach first, and then just try to optimize whenever you're building any ML system. So here again, XGBoost model, which is again a tree-based classifier, train the model, and just training, and then just training on once we have divided the data set in training and testing, and then you can test the XGBoost model. Then with the small data set, because this German credit, it has like the 1,000 entries. So with that, the accuracy is coming out to be like 85%, which is fair enough, and this is kind of a classification report you can get, which is precision recall. These are all evaluation metrics whenever you're doing this classification kind of a problem that you're trying to solve. So here the accuracy of the model is 85%. I'll show what are the fairness techniques once we need to understand what is a fairness in our subsequent slides. So that's how we can use one of the techniques that I've described, how to build unbiased and fair models. Next. Okay, what is algorithmic fairness? As I promised, that's too much. I think it's very important when we are building unbiased and fair models. But we need to ensure that our modeling is fair enough, whether it's justifiable, whether it's reliable enough versus not. So for that, let's see. Okay, so the fairness basically happens with regards to the two, I would say brackets. The first with regards to the fairness, protected attributes or the sensitive attributes. As we have seen in this German credit data set, there were like a couple of protected attributes, like the gender, age, right? And why we want to, so basically when you are building the fairness in models with regards to the protected attributes, you don't want the bias should be inherited, right? Or I can give an example as, the loans should be sanctioned irrespective of the user's gender or, their age. Of course, lending authorities are free to make their own protocol, but eliminating just on the basis of the gender, it's so not good, or I would say not a correct lens and looking into things. And the second is, fairness with regards to the outcomes. So basically when the model should not harm, or it should not even benefit one particular group or an individual. I think there was a famous Amazon hiring algorithm, which was so much famous in last couple of years that so what happens in the Amazon's hiring algorithm was that it was discarding actually the women applicants who had the same level of experience and the skills as compared to the male counterparts, though it was scraped off after after so much in news it came out to be. But the underlying fact, or I would say the learning, is that the model should not disadvantage one particular group over the another based on just on the protected attributes or on the sensitive attributes. So that's how the fairness is being categorized with regards to the outcomes, with regards to protected attributes. And let's see some strategies that we can incorporate while we are building and modeling our ML system or the use case that we are catering to. So the first is demographic parity. Of course, there are other fairness strategies that we can use, but these are like very intuitive to understand, and that's why I've included them here. The first is demographic parity. So basically, demographic parity, it just ensures that your model's predictions, they are similar across all possible demographic groups. Let's say, if the loan prediction, it's trained on unequal distribution of the different ethnic groups, then the demographic parity will ensure that the model provides similar loan rates across all the ethnic groups. And the second is the statistical parity. In the statistical parity, basically you're trying to calculate, the difference in probability of the true positive, or I would say the positive outcomes between the privileged and unprivileged group. Now here I'm using the word, which is, or I would say the phrase that is privileged and unprivileged group. I'll explain what is it once I'll show the demo, for all these, couple of the strategies, fairness strategies. And the equal opportunity difference, it's basically also finding for difference in the probability of the positive outcomes between the two, or I would say the true positive rate between the privileged and unprivileged group. Okay, so let's see the demo of that. So again, the same use case that I'm catering to, loan classification, German credit data set, right? And here, after we have done the modeling, okay, now our model is 85% accurate. Now we need to ensure whether it is really reliable enough to be, put down to the production environment or the dev stage or no, or just that it is fair enough versus not. So for that, the fairness techniques, which I've explained in my previous slide before, here I'm using first is equal opportunity difference, which is again calculating the true positive rate on the basis of the privileged and unprivileged group. So, okay, when I meant by the privileged and unprivileged group, so in the entire data set which is being given, you need to do some hypothesis testing. So what I meant by the hypothesis testing is in a sense that you define your privileged group in a sense, like I have defined the way, that all the men beyond the age of the 18 should be a privileged group, and unprivileged group is all the women beyond the age of 18 for loan classification problem. And why I have defined it once I have done the hypothesis testing, which is definitely not included in this as a part of this collab or slash this, because it's a different topic altogether to the do hypothesis testing. But for the time being, and also I have, so when you also do the EDA, you will understand how many instances of the male and the female, other gender or maybe like other sensitive attribute spaces kind of features are available. So in that way, you can define your unprivileged and the privileged group, and then you test certain algorithms on top of it. You see, okay, now our model has been trained. Is that model reliable enough versus not? So in this equal opportunity, you are taking like a couple of params as an arguments, like here the y true, y prediction. Once we have done the prediction of a model, so it gives you the y pred, right? And then you add the sensitive features, which all sensitive features you want to define right now, which is already given in your data set. Then privileged and unprivileged group, and then you calculate, the difference in that. So here from this example, I can see, oh, the equal portion difference is equal. It's the result which is coming out with like 0. So that's what we need, right? So we don't want the difference to be like huge at the same time, but you're also put in, you can free to, just tweak around it and put your own threshold based on the use case and slash other logistics that you have or the objectives that you're trying to achieve. So here the 0 basically it implies, okay, the model's performance in identifying the positive instances, it's consistent. It's not creating any kind of a bias over the privileged and unprivileged group. Maybe like it's, in the sense that it's not favoring one group over the another. So that's an equal portion difference. Similarly, you can calculate the statistical parity, which is again the difference between, we calculate the privileged and unprivileged group and just calculate the mean beyond, within your data set. So here the statistical parity difference is also like a bit less, which is what we needed. And that's how the good hypothesis, okay, now our hypothesis is right. Okay, this model is good and fair enough. So we can definitely deploy it into the, whichever the environment that we want to do it. So that's how we can incorporate the fairness techniques. Let's see. Okay, now the main and the core part is, okay, we need to, once we have defined all this, fairness model is fair enough, can we also do the testing onto it? We just want the model not just being fair enough, but it's also time for us to introspect every particular component of the system that we are developing. So in that way, so ML test pyramid is also like, it's not kind of a traditional software testing that we do. It's very much different. Basically you're testing each and individual components, like you're doing unit testing. So you're just testing, okay, data pre-processing, feature extraction and all these stages. Or you're just doing integration testing, verifying other the components which are interacting with your ML system. And then model testing is, like the accuracy, precision, recall. These are certain metrics that you can use to evaluate your model, as I've shown in this loan classification problem. And there is robustness testing, which is also like whenever there are some edge cases, some outliers, which might be possible in your data set. So you can do some some testing on the robustness. Just wanted to ensure, that your model is performing like really well on the unseen data set as well? Or is it like reliable enough when you're deploying in the real world scenarios? And especially I would highlight the testing for the robustness is so vital, because it helps in giving the gist to the developers. Okay, it's not creating the haywire results when the input is getting varied, right? So if there could be some input variations, they could meet some adversary attacks, or maybe some edge cases which are crucial or must have not been entertained while you were developing. So that robustness testing actually covers the entire breadth, or I would say the entire, all the, like 360 view around it. So that's how the robustness testing, and then you can do some deployment testing basically just to ensure that smooth CI/CD pipeline is going on, and just validating a model's performance not getting degraded over the period of time. Ethical and fairness testing, couple of examples I've given like in fairness testing that you can do. Ethical testing again is very much important because you want to ensure of privacy concerns. There are some algorithm bias, like the algorithm bias is word to wake, right? That it's one of the bias in the algorithm in itself. So you should be very much cautious whenever you're using that word to wake algorithm. And of course, could be some unintended consequences which might be possible. So you need to ensure that you cover the 360 view while we are testing the machine learning system end to end. So let's see, I think there is another demo. I've added a couple of demos so that people are more, so that I think it's important to impart the knowledge once you have understand a lot of theory, then just to make it much more cemented in your in your in yourself. It's important to have multiple demos to understand it thoroughly. Okay, so for the demo case, I think I have it. Perfect. Okay, so the sentiment classifier. This is one of the very basic example, but I really enjoy while I'm giving and explaining about how we can do integrate the ML testing while we are, building ML systems. But before that, I have need to explain what is the sentiment analysis and how we are doing the testing of the sentiment analysis. So I think I would say now I'm also taking an opportunity to thank all the organizers of this PyCon particle. And of course, there are so many people which are revolved around it and making this conference a reality and giving all the speakers an opportunity to share their learnings with all of you people. So it's kind of a positive sentiment, right? And I would say a negative sentiment could be, I definitely don't like pineapple on a pizza. While my brother, or I've seen like so many of my friends definitely love it. I'm not sure people within the audience love it or not, but definitely pineapple on a pizza, it's not a good combination. So that's a negative sentiment, right? And positive again, yeah, so it's like, I can say, oh, I really it would have been a fortunate opportunity. I would have traveled to the, PyCon Portugal, but again, the circumstance didn't work out. So, but I still enjoying and sharing my learnings with all of you. So it's kind of a mixed sentiment, but I think more highlighted towards a positive, right? So it's a positive sentiment in that case. So the sentiment classifier that I'm trying to build right now is, given a text, you need to identify whether it's a positive / a negative sentiment. That's use case. Okay, so you do, of course, the pre-processing stage, then you build a pipeline, and of course you're using the very basic classifier here, and then you're training and predicting the sentiment. Here, not text implies that, okay, if the text is not being given by the user, then of course there is no sentiment which is attached to it. And if there is text being given, then you need to see how the model is being trained and and what corresponding sentiment is going to be. And here the classifier, okay, now this entire class is created. I want to test on the sample training data. It's a very tiny data that I've taken just for the demo purpose again. So here the text is, I love the beaches at California, which I definitely enjoyed throughout. So it's a 1, right? 1 is a positive and the 0 is a negative, right? So this movie is terrible. We have so many attendees at this PyCon Portugal conference. So again, so it's kind of a, 1. So here in that case, you can use, that's how you build the sentiment classifier. And then of course, when you have to test it, you build some testing, and I'm using the PyTest, which is one of the frameworks that I'm trying to, once we have built and whether how the model is performing and just checking it out, whether the outcomes or the predictions are right or not. So I think, let me actually. Okay, so sentiment classifier, I just wanted to run it quickly because I know I got an alert that, okay, I'm very much lacking behind my talk. But I think, yeah, so if you just run this will definitely work out. And just wanted to highlight that, using the PyTest is also like one such framework that you can use whenever you are doing this, testing. Okay. So the next topic is, I think I wanted this to be very much interactive, but considering the time limit that I have, so I just wanted to do a quick question that, who should be the responsible if the model is giving any kind of a, haywire results, whether I think I would say, is it the developers as we, or, the business leaders or the regulatory bodies and the end users? Well, the answer is, all together of us should share the equal response because everyone is contributing towards whenever we are building such systems. So no one should really like pinpoint it, but in fact, like it's collective effort altogether. So if I want to plug in the explainability, which implies that I want it to be like human readable or understandable, then how can we plug when we are building such black boxes? So in this explainability, you have multiple algorithms that you can use whenever you're building such explainable models. And I can give you an example as, let's say you are a data scientist and you're working for a credit card company. And your task is to build some kind of a model which helps in predicting whether the card transaction is a fraudulent versus not, or just wanted to whether it's a transaction is a fraudulent versus not. So then you will build a model which will make the user understand, oh, your transaction has been cancelled, but because maybe you are doing a transaction from such location which you have never done before, right? So that kind of an alert or human understandable is how we can plug the explainability when we are building such systems. And I wanted to show a quick demo of the explainability as well, which I think I will be able to cover it very quickly. Okay, so in the explainability, I'm giving you, here I'm using the Lime as one such package. And once you have used this package, then you can see, okay, let's say the testing on I've done is so exciting to be presented at this PyCon particle conference. Here, you can see all the highlighted words, and it's a positive sentiment, right? And why it is positive, so you can see the highlighted words. So it's so much human readable, right? So that's how we can plug in the explainability while we are building such systems. Okay. And last is again the conclusion. So of course, building fair, accountable, and trustworthy machine learning systems is very much critical while we are ensuring, it should be accessible and inclusive at the same time. We should need to ensure that its monitor and evaluation is equally important while we are building such systems. And these are a bunch of resources. Special shout out to the second course, which is Introduction to Deep Learning. It's by MIT, and I would definitely recommend people to check it out. And yeah, I really enjoy writing a lot. So I just written like a couple of words for all of you to understand, or maybe like just to see and give me any feedback as possible. So from the data's haze to the ethics place in ML's maze, let's shine the fair rays, right? Inclusion is our mission for sure, and the colorful composition, and therefore we need to erase the bias, and that should be our unwavering vision. So I really hope this talk was fruitful for all of you. I know I was behind so much time, and please reach out to me. And I've definitely included the previous icon of the Twitter, but yeah, definitely reach out to me. The handle is the same. I'll be more than happy to any questions that you have. And of course, I don't have the time for the moment, but of course, you're just free to reach out to me on Twitter. I'll be more than happy to discuss on it. Thank you so much, everyone. And thank you for being a lovely audience.